Saturn V Quarterly Film Report number 11 covers progress during the period June, July, and August 1965. Development, manufacturing, and testing of S-1C stages by the Boeing Company and the Marshall Center continued throughout the quarter. The first full duration or 150-second static firing of an S-1C stage was successfully performed on August 5th at the Marshall Center. The 5 F-1 engines of the test stage S-1CT produced full thrust of 7.5 million pounds. All 4 outer engines were gimbaled satisfactorily. The first firing using automatic checkout equipment is presently scheduled for next quarter. Marshall assembly of the first Saturn V booster flight stage S-1C1 neared completion this quarter. The intertank LOX tank forward skirt assembly was completed in late June and was transferred from the vertical assembly building to the horizontal assembly area for mating to the fuel tank thrust structure assembly, which had been finished last quarter. Splicing of the 2 tank assemblies was accomplished on July 12th. Miscellaneous mechanical and electrical work is continuing. Installation of the 5 F-1 engines was finished August 28th. The completed stage is scheduled for turnover to the Quality and Reliability Assurance Lab for checkout on September 27th. Assembly of the second flight stage, S-1C2, also moved forward at Marshall. Hydrostatic testing of the fuel tank was completed in mid-August. In addition, the skin assemblies were welded to both the upper and lower LOX tank bulkheads, and thrust structure assembly was continued at MSFC. In Marshall's load test tower, the intertank for the S-1CS structural test stage was installed atop the fuel tank thrust structure assembly in mid-July, and preparations are underway for structural load testing of the unit beginning in September. At Marshall's Michoud assembly facility in New Orleans, the Boeing Company achieved an important goal on June 27th when the first S-1C stage to be assembled at Michoud was removed from the vertical assembly building. The S-1CD dynamic test stage was moved to the horizontal installation position in the plant area where installation of tubing and wiring is underway. The thrust structure for the S-1CF facilities checkout stage was moved into the VAB in mid-July. S-1CF will be the second stage to be assembled at Michoud and the first to be checked out in the new stage test building. After completion of hydrostatic testing, the fuel tank for S-1CF was moved into the vertical assembly position and mated to the thrust structure. Here, the 5 LOX suction ducts were installed. The intertank, LOX tank, and forward skirt were added to complete vertical assembly of the stage. The S-1CF was removed from the VAB on August 26th and transferred to the horizontal assembly area. Bulkheads for S-1C3 and 4 flight stages were completed during the quarter, and work was underway on S-1C5 bulkheads. S-1C3 was in the final phases of major component assembly, while similar operations for S-1C4 were just getting underway. Assembly of S-1C5 will start next quarter. A change in manufacturing technique was inaugurated by Boeing in the form of the pocket-milled or T-stiffened Y-ring. The application of this change will be used in S-1C4 and subsequent stages. The new type of Y-ring will add strength as well as delete 5,000 pounds of weight from the S-1C stage. The first successful full-duration 395-second cluster firing of the 5 J-2 engines of the S-2 battleship stage was accomplished on August 9th by North American Aviation Space and Information Systems Division at the Santa Susana Field Laboratory. 4 earlier attempts to fire full duration had been terminated prematurely due to various malfunctions, all of which were later rectified. The battleship is now being prepared for the next phase of testing, which includes flight engines, gimbal systems, and propellant utilization. After completion of the S2 common bulkhead test tank late last quarter, the tank arrived at Santa Susana on June 3rd. The gaseous nitrogen burst pressure test was successfully conducted on July 10th. Cryogenic fill and drain tests had to be postponed because of insulation problems. Repairs to insulation were made, facility activation completed, and testing was resumed on August 21st. At SNID's Seal Beach facility, modification of the test tower for the structural test's dynamic test stage was completed on July 16th. Body and flight load tests were completed on August 15th. These loads simulate the inertia of the S4B stage and Apollo spacecraft. Completion and ultrasonic inspection of bulkheads for the S2 facilities checkout stage were accomplished during the report period. Stage structural assembly and pneumostatic testing have been completed, and the stage moved to Station 5 for cleaning. The S2T all-systems stage was inverted and placed on the stage hydrostat fixture for cleaning of liquid hydrogen tanks in July. The LOX tank had previously been cleaned with Freon. While in Station 5, the liquid hydrogen feed lines were also installed. The stage was then inverted to a thrust structure down attitude and returned to Station 2 for further component installation. The 5 J2 engines were also installed on the thrust structure during August. Shipment of S2T to Marshall's Mississippi Test Facility is expected early next quarter. The common bulkhead for S21, the first flight stage, has been completed, and manufacture of bulkheads for flight stages 2 and 3 is in progress. At the electromechanical mock-up stage simulator area at S&ID's Downey facility, checkout of the S2 separation system was successfully performed during the report period. All S2 stage electrical and mechanical functions can be performed or simulated by the EMM. Development of the basic program tapes was completed, and the EMM functional demonstration was successfully accomplished. The S4B facilities checkout stage underwent final installation of equipment such as this auxiliary propulsion system module early this quarter at Douglas Aircraft Company's Alpha Complex, Sacramento test facility, following successful completion of propellant loading tests at SACTO's Beta Complex. The facilities checkout stage left Sacramento by ship June 10th on its way via the Panama Canal to the Kennedy Space Center for use there in Launch Complex 34 checkout operations. Following completion of Saturn Ib configuration battleship stage testing last quarter, a J2 engine with restart capability was installed in preparation for Saturn V battleship testing. During the initial test on July 1st, a fire broke out as a result of an accumulation of hydrogen in the upper thrust cone area, and the program was delayed approximately 1 month for refurbishment of damaged components such as wiring and tubing. The first successful full-duration battleship firing with restart was accomplished on August 17th. The stage's J2 engine ran for 3 minutes before being cut off for a 30-minute simulated orbital coast period. It was then reignited for a 355-second run. A similar test on August 20th concluded the battleship firing program at SACTO. Beta Stand Number 1 will now be modified for use in acceptance testing of flight stages. Construction of the vertical checkout laboratory at SACTO continued with installation of ground support equipment. The facility will be used for post-static checkout of flight stages. At the Douglas Huntington Beach plant, fabrication and assembly continued on the first 2 S4B5 flight stages, 501 and 502. After removal from insulation chambers, 501 was transferred to the assembly checkout tower complex for installation of components in the LH2 tank. The propellant tanks for the 502 stage are being assembled in position number 1 of the complex. The S2 forward skirt has been received from SNID for use in conjunction with the S4B aft interstage testing at Douglas next quarter. Conversion hardware for converting the S4B-1B dynamic stage to a Saturn V configuration was weighed and balanced at Huntington Beach, prior to shipment to the Marshall Center in August. The forward skirt will be used in dynamic testing of the S-4BD instrument unit and Apollo spacecraft in October. The aft interstage will be stored until needed next year for dynamic testing of the entire Saturn V vehicle. The first J-2 engine delivered by Rocketdyne to Marshall underwent initial static firing during August in the center's new S-4B battleship test stand. The first of a series of environmental tests of the F-1 engine was conducted by Rocketdyne in July at Test Stand 1E, Edwards Field Laboratory, California. Successful start and operation of the engine system was accomplished after high-temperature conditioning at 135 degrees Fahrenheit for 16 hours. Later, a successful firing was performed following a low-temperature environmental test simulating possible hold conditions at launch. At Rocketdyne's Canoga Park, California plant, a program aimed at improvement of F-1 engine thrust chamber assembly techniques was underway as a result of hot gas leakage experienced in some recent production engines. This series of operations, which is expected to solve the problem, covers assembly of the thrust chamber up to the point of installation in the brazing furnace. Activation of Rocketdyne's new manufacturing building number 4 at Canoga Park is scheduled in early September. F-1 turbopump and valve assembly operations were transferred to the new facility from manufacturing building number 1 in mid-August. 2 large clean rooms were also readied for use. The Marshall Center's new single-position F-1 engine static test stand was activated on July 8th with a successful 10-second firing. On July 21st, a full-duration 150-second firing of the 1.5 million pound thrust engine was successfully performed. In all, 12 firings totaling 16.5 minutes were held in the new stand this quarter. All 5 F-1 engines for the first Saturn V flight stage, S1C1, were received at Marshall from Rocketdyne during the report period and underwent checkout and minor modification before being installed in late August. The J-2 engine flight rating test series, which was begun by Rocketdyne in May, was completed on July 21st at Santa Susana. A total of 25 firings accumulating 46 minutes was performed. Deficiencies found during the FRT series will be corrected prior to completion of engine qualification. Teardown of the FRT engine J2023 for engineering inspection began in August. Engine number J2032 was acceptance tested, and the 200K qualification test series will begin at Delta II test stand next quarter. Qualification tests are due to be completed by December 31st. The last of the 5 J-2 engines for the S2 all-systems stage was delivered to S&ID in June. Rocketdyne has inaugurated use of a 4-axis numerical control measuring inspection machine in connection with J-2 injector assembly. This automatic technique permits time reduction as well as increased reliability of measurement data and fulfills the Rocketdyne integrated systems approach of employing numerical control from design intent to finished component. Throughout the quarter, ground test instrument units were assembled and tested. Design changes necessitated partial reassembly of the flight systems instrument unit at Marshall this quarter. Checkout is due in October. Assembly got underway on the breadboard test unit 500 ST. The vibration test unit was completed and delivered to Wiley Labs, Huntsville, Alabama on August 20th. Testing will begin early next quarter. The facilities checkout unit was shipped to Kennedy Space Center upon completion of assembly at Marshall in June. Virtually all Saturn V load tests on the structural test unit have been successfully completed. Based on test results, the access door is being re-evaluated, and further testing in this area may be conducted next quarter. A second structural test unit assembled by IBM Huntsville using segments manufactured by North American Aviation was rejected by Marshall due to discrepancies. Another unit is now in assembly, scheduled for delivery September 30th. The Marshall Center's 18.5-acre Saturn V service arm umbilical test facility, shown in this artist's drawing, neared completion during the report period and is scheduled for activation next quarter. The new MSFC aerial will provide extensive facilities for testing of the 4 hold-down arms, 3 tail service masts, and 9 service arms, depicted here in model form, that are to be used on the mobile launcher for Launch Complex 39 at Kennedy Space Center. Prior to official activation of the entire test facility, the hold-down arm test pad was in use this quarter. Testing of the initial set of hold-down arms was completed in late July, and testing of a second set is currently in progress. The first set has been shipped to KSC for installation at Complex 39. Initial checkout and testing of the first of the facility's 8 vehicle motion simulators, this one for the Apollo Command Module mock-up, were accomplished this quarter. The simulator is driven by a hydraulic servo system capable of simulating total movement between vehicle and launcher during pre-launch and launch conditions produced by very high winds. Each simulator duplicates that portion of the vehicle's skin containing associated umbilical connections and personnel access hatches. 5 of the facility's 8 simulators are equipped with elevator devices that simulate liftoff of the Saturn V vehicle. The liftoff simulators were tested for the first time this quarter. The elevator accelerates for a distance of 8 feet with total travel of 11 feet 8 inches. At Marshall's Mississippi Test Facility, progress continued on construction of the test complex's S2 stage static test stands, designated A2 and A1, and the dual position S1C stage static test stand. On June 30th, the S2 fit-up fixture, which simulates the size and weight of the stage, became the first Saturn program article shipped through MTF's new lock system. The fixture was hung in the S2A2 test stand in August. Construction and activation continued during the report period on facilities in MTF's Laboratory and Engineering Complex and Support Services Complex. In summary, June, July, and August 1965 were months of continuing Saturn V program advancement with milestones such as the first full-duration 5-engine static firing of an S1C stage, near completion of assembly of the first S1C flight stage, the first successful full-duration 5-engine firing of the S2 battleship stage, the first S4B5 battleship stage static firing, the beginning of F1 engine environmental testing, completion of J2 engine flight rating tests, assembly and testing of various ground test instrument units, and initial testing of Saturn V ground support equipment.